This is concept 38 part 1. In this one we talk about the properties of rhombi. Rhombi is more than one rhombus. Rhombi have the same properties of parallelograms. Pause the video here and familiarize yourselves with the 5 properties again. And a rhombus has these 5 properties plus 3 new ones. They are all four sides are congruent, or all 4 sides are equal. Diagonals are perpendicular, and recall that perpendicular means angles formed are 90 degrees, and these look like this. Okay, so 2 lines meet and they form a perfect 90-degree angle. And the third property is diagonals bisect opposite angles. So in this case, for rhombus or for rhombi, you have the diagonals cut the opposite angles into 2 equal parts. For our examples, we have each quadrilateral below is a rhombus. Find the missing measures. JK is 12, so let's go ahead and label that up there. JN is one of the half diagonals there. And then it says, what's JM? JM is this side here, and all 4 sides are congruent in a rhombus. So if JK is 12, JM is also 12. JL is the entire diagonal here. So if half of it is 7, half is 7, the entire thing is 7 times 2 or 14. MN is the other diagonal here. Now, where a lot of students get confused with properties of rhombi is they assume that the diagonals are equal. We cannot assume that, okay? We have to stick to what the properties are, and none of these say or suggest that they are equal. Now, we're going to be using the idea of number 2 here, that the diagonals are perpendicular. And what we mean is, when they meet in the center, right, just taking this figure here that I have on the right, when the lines meet, they form right angles. So I have a right angle there, I have another right angle there. Okay, it's right angles all around, and it looks like a little square in between. What we're going to be doing is we can take, we're looking for MN. MN is right in the center here, MN. So we can just take this triangle here, bolded in red. And because we have a right triangle because of this right angle, okay, we can use the Pythagorean theorem to find MN, which is this one right here that I'm tracing. Okay, now JM, again, all 4 sides are congruent, so I can say that this one is 12. And I drew this arrow because you recall from our previous unit that C, when I use my Pythagorean theorem of a squared plus b squared equals c squared, C is always the one directly across from the right angle. So I'm given C is 12, and I'm given, and you can label this as A or B, I'm given 7, so we'll just call that one A. So for MN, so here's to find MN. Okay, I have 7 squared plus b squared is equal to 12 squared. 7 squared is 49 plus b squared, that's equal to 144. And if I subtract 49 from both sides, I get that b squared is equal to 95. And then remember to cancel out this exponent. I don't want b squared, I want just b. Okay, you take the square root of both sides, and that cancels out the exponent and the square root, and you get that b is equal to, and then type this in your calculators, you're going to get 9.7. So mn, again, mn, that's my b, right here, is 9.7. mk is the entire thing, so half of it is 9.7. The entire thing would be multiply this by 2, and you get 19.4. And that's it for this one. Number 2, it says EF is 23, so right there. DF is the entire diagonal here, okay, 40. So let me use red for this one. That one's 40. And it says, what is GF? GF is the other side here, and again, all four sides are congruent, so GF is also 23. HF, where's HF? Here's H, here's F, so HF is half this diagonal. If the entire thing is 40, okay, this thing would be half of 40, or 20. GH is half the other diagonal. So we're gonna pause here and then use the, and ignore the car if you can hear it, I apologize for that. Okay, so GH is right here. We're gonna use the diagonals are perpendicular, so I'm gonna draw my right angle here. Okay, and we're looking at this red triangle that I am bolding here. Okay, and we know this side is 20 because we already found HF, half this entire diagonal. So this triangle is, let me draw my arrow. I'm given C and I'm given one of the legs, so I am finding B. Ignore the fireworks as well if you can hear them. A squared plus B squared is equal to C squared. I'm given C, I'm given A, so I have, so to find GH, I have 20 squared plus B squared is equal to 23 squared. I get 400 plus B squared is equal to 123 times 23. I get 529. And then if I subtract 400 from both sides, I get that B squared. I'm not going to write that in because I'm running out of space. But if I subtract 400 from both sides, I get B squared is equal to 129. And then again, you can take the square root of both sides to cancel out the exponent, and I get that B is equal to 11.4. So this side here, okay, we just found this one, GH, is 11.4. We labeled it here as well. We're finding GH. So 11.4. This one's hard to see. 11.4. So GE, here's G. GE is the entire diagonal. Half of it is 11.4. The entire thing would be multiply this by 2. 11.4 times 2 is 22.8. Number 3, we have RT. That's one diagonal is 22. So I have 22 going across there. And US is 18. Oh, that's going to be hard. I'm not going to write in US because I'm going to overlap the one I just drew in there. So then it says, what's VT? VT, V is in the center. It's hard to see now, but V is right there. So VT is half, VT is half this diagonal. If the entire thing is 22, half of it is 22 divided by 2, or 11. So then this one here is 11. UV is from here to here. Okay, it's half this diagonal. If the entire thing is 18, 18 divided by 2 is 9. RS, that's one of the outside lengths. So we can pause here, and we're going to use our idea of, or sorry, our property of that diagonals are perpendicular again, and it's going to require us to use the Pythagorean theorem. So if, let me write in the other two lengths I know. So I know that one's 9, and I know this one's 9. Okay, and the entire thing is 11. Sorry, 22. The entire thing is 22, so half of it is 11. The other half here is also 11. So what I'm going to do now is I'm going to take, because I'm finding RS, I'm going to take this red triangle here. And we know that the diagonals form perpendicular, are perpendicular at the center there. It's hard to see. And then here is my right triangle. I have A, I have B, and this time C is my missing side. Okay, so to find RS, I'm doing A squared, which is 9. 9 squared plus B squared, 11 squared, is equal to C squared. I have 81 plus 121. That's equal to C squared, and I get 202 is equal to C squared. Take the square root of both sides, and I get that C, which is RS, is equal to 14.2. So RS is 14.2. So if the outside length, whoops, messed this one up, 14.2, ST is the other length here, but we know that in a rhombus all four sides are congruent. So if one, I mean they're all equal, so if this one's 14.2, ST is also 14.2. Number 4, we have angles inside a rhombus. So, and they only give us one. We start with this one here, is 38 degrees, and they're asking us to find all the other angles here. So I'm going to use red, and let's see, we're going to be using this one, the third property of a rhombus. Diagonals bisect opposite angles. And remember, bisect means to cut into two equal parts. Okay, this is going to make these type of angle problems a lot easier, because that means that each angle is cut into two equal parts. You can assume that if this one is 38, angle 3 is also 38, because they're bisected. Okay, it's cut right into two parts, two equal parts. So this is 38. Okay, and then if you notice, we have that property as well, that opposite angles are congruent. Okay, so if these two are 38, then the opposite angles 4 and 5 also need to be 38. So I have 38 here and 38 there. Angle 8, we know that the diagonals are perpendicular. The angles formed are 90. Whoops. The angles formed are 90 degrees. So there you go. Angle 8 is 90 degrees. Angle 7, we're missing. Let's see. We're missing 7, 6, 1, and 2. Now these are opposite angles. So as soon as we find one pair, we know that the other has to be equal as well. So the property we're going to be using here, and let me write in the rest because it's bothering me. Okay, so we found those as well. Those are each 38 degrees. So we're going to use, let's see, this one here, the fourth one. Okay, consecutive angles are supplementary. So angle 3, this one 38, okay, and this one 38, plus these angles here, they need to equal 180 degrees because they're supplementary. So I know that 38 and 38, so 38 plus 38 is equal to 76. So this entire angle is 76. This one plus this one need to equal 180. So 38 plus 38 plus angle 1 plus angle 2 equal 180. 38 plus 38 is 76. So 76 plus angle 1 plus angle 2 is equal to 180. Okay, and I subtract 76 from both sides, and I get that angle 1 and angle 2 are equal to 104. Okay. But we also know that they are bisected by this diagonal, meaning that they're cut into two equal parts, meaning the angle 1 and angle 2 are the same, they're equal. So you can call this one x, okay? And you get 2x, running out of space, you get that 2x is equal to 104. And then when you divide or solve for x there, you get that x is equal to 52. So then angle 1 is 52, angle 2 is 52, and these are opposite, they are also equal, so they are all 52 degrees. And that's that one. Last one here for rhombi, we have zy. Let's see. Zy is 34. Wy is the diagonal. We have that it's 38. So that one's 38. And the measure of zxy, here's z, there's x, there's y, is 34. So this one is 34 degrees. WZ is, whoops, WZ is this one here. Okay, if one side is 34, and again we know that all four sides are equal, this one is also 34. So that one's 34, and then we can go ahead and label the rest here because they're all going to be the same. VY is from the center to here. It's half this. It's half this entire diagonal. We know the diagonal is 38, so half of 38 is 19. ZV, here's Z, here's V. Okay, it's half this diagonal, but we can't. Yeah, we can't assume that it's the same as the other diagonal, so we're gonna have to use Pythagorean theorem here. And what we could use is this. So there's my right angle. And we're going to use this red bolded triangle to find ZV. And we know we already found half this diagonal to be 19, so we could say that this length here, V to Y, is, whoops, that looks weird, it's 19. So we're going to use Pythagorean theorem to find ZV. And there's the opposite side. There's the opposite side. Okay, so C is given, A is given. I'm finding B. So I have to find ZV, I have 19 squared plus B squared is equal to 34 squared. 19 squared is 361. And then 34 squared is 1156. Then I get, when I subtract 361 from both sides, I get that B squared is equal to 795. And then I take the square root of both sides, and I get that B is equal to 28.2. So that's ZV. Next one would be ZX. ZX is the entire diagonal. We already found this one. So if half of it is 28.2, you multiply this by 2, and that gives you the entire thing. That's 56.4. Next, they want measure of angles. Measure of WXZ. So here's WXZ. And again, this diagonal bisects the angle, so it cuts into two equal parts. If this one's 38, this one is also 38. So we could write that in. And whoops, not 38, sorry. My writing's so small that I messed up here. This angle is 34 degrees because it's given here. So this one is 34 degrees. WVZ is this one here, and we know that the diagonals bisect each other, so it's a 90 degree. That's a 90 degree, so that's that one. Z, let's see, here's Z, ZY, W, ZY, W is right here, so we're looking for this angle here. Now we know this one's 34 and 34, and then the consecutive interior angles need to add up to 180. So I have 34 plus 34 plus this angle need to equal 180. So let's go ahead and write that out. 34 degrees plus 34 degrees, and I'm just going to call the entire thing in blue. Let's use blue. Okay, so my blue angle there, we'll call that X, okay, is equal to 180 degrees. 34 plus 34 is 68, plus, let's use this, and then I get that X is equal to, when I subtract 68 from both sides, I get that X is equal to 112. Okay, let me box this in blue. So that's the entire blue angle, and again, it's bisected, so it's cut into two equal parts. If you divide this value here by 2, it gives you each one, this one and this one. Okay, so 112 divided by 2 is 56. So each one, let's see, this one is 56, this one is 56. So Z, going back, so whoops, so Z Y W is 56, and X Y W, here's X, there's Y, there's W, is also 56. And that wraps up this part on rhombus or rhombi.